Welcome back, friends. So in this video we will be working on project number 15, that is calories burn prediction using XGBRegressor. So the dataset we will be using is provided by the Kaggle, and it is Kaggle burning dataset, and I will be providing the link of the dataset in the description so you can download from there. So we have to download two files. The first one is the calories and the second one is the exercise. Calories dataset contains only two columns. The first one is the user ID and the second one is the calories, whereas in exercise.csv we have 8 columns: user ID, gender, age, and so on, and all other columns, and we have to predict how much calories are burnt, and calories burnt are written here according to the corresponding user ID. Okay, so moving towards our project, first we will be importing all our libraries. Import numpy as np, import pandas as pd from sklearn dot model selection, model selection, import train testplate. Then we have to import our model algorithm, that is from XGBoost. Import XGBRegressor from sklearn. Import matrix metri matrix, and then we have to import matplot. So import matplot library dot plt as plt. Okay, let's run. So first one is the numpy that is used to create arrays. Then we have pandas that is used to convert our dataset into pandas data structure. Then we have train testplate that is used to split our dataset into training and test data. Then we have XGBRegressor, that is algorithm that will be used to train our model. Then we have matrix that will be used to find the accuracy of our model. Then matplot and seaborn are used for plotting graphs. Now first let me upload the two files. We have downloads, exercise, and calories. Okay, so remember that the warning shows that if you rerun the session, these two files will be deleted. So what you can do, you can either upload your files in the Google Drive and just update the path, or you can simply temporarily add files here, but your files will be deleted once the session is restarted. Okay, so let's collect the data. So data collection, calories, we have pandas.read csv, exercise, yeah, both. Let's go for calories first. Then calories dot head, it will print the first 5 rows. So we have first 5 rows with user ID and calories as 2 columns. Now let's collect data from exercise file. Exercise, yeah, just, and then exercise dot head. So we have both the files here. So as you can see, for the user ID 147333363, our calories burnt is 231 and we have to predict this calories column. Okay, now what we can do, as we have two files and two data structures are there, so what I can do, we can combine these two data set. Okay, so let's add a comment combining two data set, calories, just let's go with data set. I will say calories data set, calories data, it is which pandas dot concatenate. Yeah, so it will concatenate both the files. Let's print the first 5 rows, calories dot head. So we have both the data sets. So let me explain what I did here. I concatenate the exercise file, and from the calories I have only appended the calories column because we already have user ID. Okay, so access1 means column. So our data set is ready. Now let's print the number of rows and columns. So calories data dot shape, it will print, yeah. So we have 15,000 rows with 9 columns. That's a huge amount of data. And now let's print basic information, calories data dot info. It will print number of rows and data type of the columns. So we can see that user ID has a data type of int, gender has an data type of object that we need to convert into numerical form because our model does not know the object form, it only recognizes numerical form of data. So int and floats are okay for our model, but object is not. Now what we can do, as we do not have any missing values, that's good for our project. Now let's see the statistical measures. We have calories data dot describe, it will give the statistical measures. So we have mean of 1.49, user IDs does not add any significance, so we will remove it later on. So second one is the age, average age is 42 and with minimum age of 20 and maximum age of 79, and 25% means 25% of the value is less than 28, 50% of the value is less than 39, and 75% of the value is less than 56. Okay, so let's do some data visualization. Like for data visualization, what we will do, visualization, first we will set our SNS, and now we will plot the gender column. So SNS dot count plot to count that how many different sex are there. X is equals to gender data, we have calories data, yeah. So are there considerably, both are same, around 7,500. Females are slightly more, so we have a good data as we have uh, both the categories are almost same. Now let's find the distribution of the age column. Distribution of age, SNS.displot, and calories data, we have to find the age. We can see the density Mostly people are between 20 to 30 age, and it is decreasing when the age is increasing. Most of the people are of the age 20. Okay, that's good. You can check for other data columns as well. Now moving further on, we will convert our text data into numerical form. That will replace the gender, male with 1 and female with 0. Let's do it. Calories data dot replace, we have gender, we have to replace it, we have to replace male, so we have male with 1 and female with 0, and in place will be true. In place will be true. So in place is used to update our original dataset. If we will not use in place, so our original dataset will not be updated. Let's print the first 5 rows to check whether our data has updated or not. So calories data dot head. So we can see in the gender column our data has been updated. Now let's print the correlation. So what is correlation? Correlation defines the relationship between the two entities. There are two types of correlation. The first one is the positive correlation. Let me write it down. So correlation, first one is the positive correlation, the second one is the negative correlation. Positive correlation defines if one entity is increasing, the other entity will also increase. Just take an example of a house. If the area of a house is increasing, the price of the house also increases, so they are positively correlated. Then we have negative correlation. If one entity decreases, the other entity increases, so it is an example of negative correlation. So we will find the correlation among different entities. So for that we will write correlation is equals to calories data dot CORR, and then we will construct the heat map. Constructing the heat map, plt dot figure fixed size 10 by 10 is okay, fmt. Yeah, so let me tell what is it. So correlation is this correlation. If I just print correlation, it will also give me the same data, but it will not be presentable. Correlation, let me print it. As we can see, we have the correlation data, but it is not presentable, so that's why we use heat map. Okay, so we use data as correlation. C bar is this line, is known as C bar. When then we have squares, these are on the squares. Then fmt 0.1 means that after what value we can see the value, like 0.8 is there. If I update it to 2, we will see up to 2 decimal places. Yeah, as we can see, up to 2 decimal places we have there 0.78. If for simpler, I will just update it to 0.1. Okay, then we have size is 8. The font you are seeing inside the square, the size is 8. Then CMap blue, the color is blue. Okay, now what we can do, we can analyze it. So as we can see, all the diagonals are correlated by equal proportion, like from calories and calories, they are equally correlated. That is you can logically correct. And body temp and body temperature, they are equally correlated. But some other data like weight and height, they are also equally correlated, that is our analysis. Then we have gender and height is also correlated, and gender and weight is also correlated by 0.8%. So that is our analysis. Now moving on, we will separate our features and target. So what is X? X will contain all the features column, and Y will contain all the target column. Target is the output. So calories data dot drop columns is equals to, first one we don't need user ID, so we will remove it. User, the user ID is right in the, yeah, user ID. Then we do not require calories. ORI is calories with access is equals to 1, and Y will contain only the target, that is the calories column. Yeah, so we dropped the calories and user ID, and rest of the columns are in the X, and Y has the target column, that is the calories. Let's print X and Y. So our data is correct. X has all the column except user ID and calories, and Y has all the calories column. Now we will split our data into training and test data. X train, X test, Y train, Y test is equals to train test split. Then we have both the original data set, and our test size should be 20% and administrator 2. Okay, administrator 2 is good. So we have 20% as test data and remaining 80% as train data. So let's print the shape. So X dot shape. So originally we had 15,000 rows, but after splitting into training and test, 80% has train, that is 12,000, and remaining 20% in test data, that is 3,000. Okay, now we will do model training. So for that we will initialize our model. Model is equals to XGBRegressor. Let's run it. So our model has been initialized. So model.fit X train, Y train. So our model has trained. So now what we can do, we can evaluate. We will evaluate on the test data, on the training data. Okay, so prediction on training data, train data prediction model dot predict. So our predictions are there in the, now we will be calculating the accuracy. So R2 score, that is R square, R2 score is equals to matrix dot R2 score Y train print R2 score. So our model is 99.9% accurate. Now we will do same for the test data. So test data prediction model dot predict and R2 score So for the test we have 99.8%. So our model is 99.8% accurate. So that's all for now. So if you have any query regarding this project, do let me know in the comment section, and don't forget to like and subscribe. Thank you.